Imagine you see an object moving but have no idea how to describe it scientifically. What do you do? Well, you use the language of kinematics. But what is kinematics? It's just all about describing motions scientifically. This video is not going into calculus because I'm not going to learn it to make this video, and we'll be focusing on one dimension. Now a scalar quantity described as a magnitude only. This area is 10 centimeters. This is a scalar. The mass of this box is 8 grams. It's also a scalar. The mass of this table is 69 kilograms. It's also a scalar. This guy travels 69 kilometers with his skateboard. It's also a scalar. As you can see, scalar is all about magnitude. And then there's vector quantity, where it's described in magnitude and direction. For example, this guy is traveling 4 meters north, and as you can see, this is a vector where it has both magnitude and direction. So again, a scalar quantity is described in magnitude, and a vector quantity is described in both magnitude and direction. And then there's distance and displacement. So let's say, for example, let's say we have Bob here, wanted to go to his friend's house, Lob. Now, the starting point is 0 meter. Now Bob traveled 10 meters to go to Lob's house, his friend's house. But unfortunately, Lob hated Bob, so then he kicked Bob out of his house. And so Bob was crying and turns his back and go back 8 meters. And now he's now in 2 meters here. Now distance, he traveled a total of 18 meters. Displacement, in the scenario, the displacement is the difference final minus the initial. So in this case, the final is 2 minus the initial, which is 0. So 2 meter. And then there you go. Speed refers to how fast something is moving. For example, this guy is traveling 69 meters per second. What does this mean? It means every second this guy travels 69 meters. 69 meters per second. What does this mean? Okay, now let's make a table. So, here's the time, here's the speed, and in 1 second this guy travels 69 meters. In 2, you gotta like times 2, and then 3 seconds later, you have this, and then 4 seconds, and so it's basically like that. It's basically that this guy travels 69 meters every second. You can think of it that way. And so and then we have velocity, which is like speed but with direction. Now to calculate average speed, we have this formula: total distance divided by total time, or simply this. For average velocity, we have this, which is the displacement over time. So let's say that hypothetically the time is 9 seconds for this whole scenario. For this whole thing, that would be a second. Now let's find the average velocity. So our formula would be v equal d over t, and then there's 9 seconds, and we plus these two numbers, 18 meters that will be 2 meters per second. Let's calculate the average velocity. The displacement will be 2 meters, and then our time here, 9 seconds. So there's our average velocity and average speed right here. And so then, speed is a scalar which only has magnitude and should be positive, and velocity is a vector where it has both magnitude and direction and could be positive or negative. Acceleration tells you how fast the velocity is changing. Now when you hear something like 69 meters per second squared, what does this mean? Now this can also mean 69 meters per second. So if you were to look at this graph and understand it yourself, you can see that the velocity is changing, meaning is accelerating. So if the velocity is not changing, it's a constant speed. Constant speed means the velocity is not changing. Look at the graph at the left, that's the representation of a constant speed, and then over the right is the acceleration.